All right, so again, if your domain has more than one partner, so like this one right here, then that one is already not a valid function. So for this graph, this one is not a valid function, and then for this one, this is a valid function. So as long as your vertical test or vertical line is not hitting more than one point for the x-axis, then that one is a function. Right, so we have a short exercise here. So identify which of the following graphs is or are functions. So is this a valid function?
Yes, sir.
Right, so yes. How about the second one?
Yes, sir.
All right, how about the second one?
No, sir.
So this one is no, since it hits more than 1 point for your domain. How about this one?
Yes.
Yes.
So take note, when you say vertical test, so you can apply it anywhere. So from here, 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 here. Okay, and anywhere on that curve or in that um, shape, right? So whatever is that coordinate. So this one is yes. How about this one?
No.
No.
This one is no. How about this one?
No.
This one?
No,
No,
sir.
sir.
No. Okay. So the faster that you will respond to my question, the faster that we will finish this module. All right. So next week is now your final exam. So supposedly I will give that meeting as your well, this one, yeah, a time to finish all of your activities, and then yeah, as usual, we will not be meeting supposedly. But then again, I am now seeing that we will not be able to finish this module 5 today, since as of now we are still at slide 30, so just half of the topics. Anyway, so this one is no, this one is also yes or no.
No, sir.
No.
No, sir.
Very good. So when we say writing a function, this one is just basically like a relation. Okay, so we have the domain and then the codomain. So this domain is related with this codomain. So we have A1, E4, I5, and then O2. Okay, so again, this domain is your pre-image, and then your codomain is your image. So what is the pre-image of A1? What is the call this one? Image. No. What is the pre-image of 4E? Okay, what is the image of O2? Okay, so that's the way of telling things when it comes to functions. All right, so we have here algebra of functions. So we have plus, we have minus, we have multiplication, and then division. Okay, so basically, if ever you're going to combine two functions, so function 1 is being represented by f, and then function 2 is being represented by g. Okay, so function 1, function 2. And then if ever you're going to perform an addition, so this is the format for that one. So it's like distributing this x to your first function and then distributing this x to your second function. So that is why you have this new format of formula, which is f of x plus g of x. So we have the other operators, wherein the only different one here is the negative sign for the operator. And then we also have here multiplication. And then we also have here for division. So f divided by g, or f of x divided by g of x, wherein g of x should not be equal to 0. Why? Because if this one is 0, and then let's say this one is 100, or whatever is the value of your numerator, you will get an error for this one. Okay, so that is why your g of x must not be equal to 0. Right? So yeah, those are just the format for the formulas for addition, subtraction, multiplication, and then division when it comes to algebra of functions. All right, so we have examples here wherein determine the f1 plus f2 or function 1 plus function 2. Okay, so we have here the function 1 and then the function 2. So the answer for this one here is just basically just substitute this one. So 2x to your f1. Okay, so 2x. And then plus, then your f2 is x squared. So this is now your final answer. Since we cannot simplify this one a little bit more. So moving on to the next one, we have here f1 times f2. So 2x times, what is your f2? X squared. So times x squared. Okay, so you can still simplify this one. So you will arrive at 2x cubed. So are we correct on this one? Can we still simplify this one, or this is not the final form? Hello guys, are you guys still there?
Yes, sir.
2x cubed, sir, final.
So this is the final form. So 2x cubed. So I hope that you guys can follow, okay? So yeah, once you're done with those examples, so you can now do this one, trick number 3. So we have actually a total of 4 numbers, but for number 4, we have another 4. Okay? So this one is using one, subtraction, and then multiplication, and then their own corresponding functions. But for this one, we only have one specific function 1 and then one specific function 2, f of x and then g of x. And then solve those using those operators. So plus, minus, times, and then division. Right? So again, you can do this one in a Microsoft Word, or you can do this one handwritten. Right? So any questions so far regarding with your Seatwork number 3?
None, sir.
Okay.
None, sir.
So just simplify this one to its simplest form, okay? To its super simplest form. If ever there is more simpler form than that, then please do it, right? And then we have here graph of a function. So as you can see right here, this is the function wherein it's asking us to plot the function f of x is equal to 2x plus 1. So first of all, we have to assume the values for your, let's say, x coordinate. We have positive 1, 2, 3, 4, 5, and so on and so forth. Okay, and then negative for the x domain, and then the positive for your codomain, and the negative for your codomain. So we've started with negative 4 and then ended with positive 3. So those are the values that we plotted on our graph. And then as you can see right here, we have here the f of x, wherein it is the computed value when we substitute this negative 4 to our f of x. So if we have a value of negative 4, so negative 4 times 2 is negative 8 plus 1 is negative 7. So that's how we've got this 7 right here. All right. And as you can see, this negative 4, negative 7 is this coordinate. So negative 1, negative 2, negative 3, negative 4. And then this one is negative 7. All right. And so on and so forth until you will get this coordinate. Okay, so we have 3 here. Oops, sorry. 3 and then positive 7. So 3, 7, which is this one. Right? So did you guys get on how we plotted this function 2x plus 1? This is the function 2x plus 1.
Yes, sir.
Yes, sir.
Yes, sir.
Right, so just simply substitute the values of your x to this function, right? So as you guys may have noticed, your f of x is actually equal with y, okay, which is your codomain. So we have here another seatwork number 4. So all you do is do similar to this one, and then of course you have to list all of their corresponding coordinates for your x and then f of x. So we have 4 functions, right? So again, you can do this one in Microsoft Word or you can do this one handwritten. All right. So the next one here is one-to-one function, or in other words, called one injective. Okay. So this one is super simple. When we say one-to-one function, a function from x to y is said to be one-to-one if for each y is an element of y, there is at most one x is an element of x, with f of x is equal to y. All right. Meaning all of your x and then y must only have one partner. Okay. So some of them can be unused, like for example this one. But the important thing here is all of your domains must have one partner for us to be able to say that this one is a one-to-one function, right? So this is a valid function, and at the same time, this is a one-to-one function. And another one here is this one. So as you guys can see, we have two partners now for your y, okay, wherein this one now is not a one-to-one function, okay. So when we say one-to-one, one partner only for x and then one partner only for y. And then for y, we have an exception. Some of them can be unused. All right, so did you guys understand the one-to-one function?
Yes, sir.
Yes, sir.
All right, so we have another secret. So this one is super simple. Just plot this one, just like this one, and then just check whether all of your x has only one partner, and then all of your y's has only one partner. But then again, some of them can be unused, so it's okay. That one is still a one-to-one function. However, if there is one side, let's say the domain or codomain has two more partners, then that one is not a one-to-one anymore. All right, so we only have 3 numbers for this one. All right, so we also have the onto function or the surjective. Okay, so this one is if f is a function from x to y and the range of f is y, f is said to be onto, meaning all of your x and domains must have a partner. Okay, regardless of how many partners do we have, as long as all of them has a partner. Okay, if there is an unused element or coordinate, then that one is not already an onto function. Okay, so as you guys can see, this is an onto function, but of course not a one-to-one function due to this uh, double partner for your element. And for this one, so this one is not a one-to-one function due to this element having two partners. And as you guys can see, we have a missing partner for 3 and 4, which makes this one more not onto function. Right? So were you guys able to get this one?
Yes, sir.
Yes, sir.
All right. So when we say onto, all of your x and y must have a partner. As simple as that. All right. So this one is again a super easy state break. So just identify whether that one is an onto function, one-to-one function, both, or neither. All right. So we have here 5 numbers. So 1, 2, 3, 4, 5. Okay. So I forgot to put the numbering, so just follow this format. So 1, 2, 3, 4, and then 5. All right. So again, you can do this one handwritten or via Microsoft Word. Right. So did you guys get this secret number 6? No problem.
Yes, sir.
All right. So we also have here bijection, wherein it is now a combination of 1-to-1 and onto. Okay, 1-to-1 and then onto. So as you guys can see, this is 1-to-1. Okay, all of them has one partner only, and then this one is also onto, since all of them has a partner. All right, we call that one bijections from the word bi. We have the surjection and then the injection. Is that injection? Surjective and injective, not injection. All right. Anyway, so do you guys understand this one, bijections?
50%, sir.
50%? How come? This one is super easy. As long as you have met this 1-to-1 and then onto, then that one is a bijection already.
I. Okay.
Nakikinig ah. Anyway, so that's it for bijections. Super simple as long as it's 1-to-1 and onto at the same time. We call it one bijection. Right, we also have here identity function, wherein this function is always equal with another function. Okay, like for example, the value for your x here is 1, and then the value of your x here is 1 also. And as you can see, 1 times 1 is 1, and then 1 plus 0 is 1. 2 times 1 is 2, 2 plus 0 is 2. So if we have that kind of condition, then we call that one identity function. All right? Anyway, this one is super easy. And then we have here the inverse function. All right. So to make it short, your x and y will interchange with each other. Okay. So what do I mean by that? Your x will become y, your y will become x. All right. So if you're going to take a look in this example, a bijection whose function is from y to x, meaning your f of x is equal to b or f of a is equal to b, will become b is equal to a. So as you guys can see, this one now is the inverse function of this original function. So we have two formulas, or formula for that inverse function. So f of f, or inverse function of x, is equal to x, or inverse function of f is equal to x. So either of those two, they are just the same. Okay, just a different representation. So to make this lesson much more easier, so we'll just use this much more simpler formula. All right, so let's have more example when it comes to inverse function for you guys to understand what is inverse function. So let's have this example number 1. So again, when we say xy, and then it's asking us to do the inverse of that function, we're going to have a yx. So this is the inverse function of this original function. Oops. All right. So we have this function. We have xy, xy, xy. So if you're going to put or create an inverse function of this one, you're going to have a1, c2, and then b3. Right? So as simple as that, your x becomes y, your y becomes x. You just interchange. Okay, so did you guys understand now what is this inverse?
Yes, sir.
Yes, sir.
Right, so let's have more example. So this is a formula wherein it is asking us the inverse function of this formula. So we actually have 4 steps to do that one. So the first one here is replace f of x by y. Okay, your f of x will become y, which is now this one. Okay, next one here is interchange x and y. So your y here will go to this x, and then your x here will go to your y. So this is now the second step. Third step, solve for y and simplify. So it is now asking us to solve for y. So just simply transpose these two here or cross multiply, and you will arrive at this equation. So y is equal to x divided by 2. Okay, or just simply divide both sides by 2. You will get this one. All right. So actually, this is not the correct answer. Okay, but then again, we have to bring this one back to its original format, wherein this f of x will become the inverse function. Okay, or inverse function of x. Okay, so that is why we have to replace that y with inverse function of x, okay, which is equal to x divided by 2. All right, so that's how we uh, do it by those, call this one, steps. All right, so just memorize this 4 steps that we have: replace, interchange, solve for y, and then replace again. Then you have a way here to check whether your answer is really correct or no. Okay, so just substitute the value of this inverse function of x, which is x divided by 2, is equal to your x, which is 2 times y. Okay, this one 2 times y, and then your y is x divided by 2. And if you're going to simplify this one, 2 divided by 2 is 1. So 1 times x is x. So just basically brings you back to the original formula. Anyway, if you are very sure with your answer, like you're sure that you did the step-by-step process, then there's no need to check your answer. But if you're the kind of the guy who always wants to check your answer if it's really correct or no, then you can do this one. All right, so were you guys able to follow this example?
Yes, sir.
Yes,
Right.
sir.
So before, the problem of my students is they need to memorize this one. But since we are in online distance learning, then open notes as always. You don't need to memorize this one. As long as you know the concept of inverse function, then you can just simply go back on this slide 45 and then do it step by step. Anyway, we have another example here wherein we have f of x is equal to 2 raised to x. Okay, so we have two solutions for that wherein both of them are correct. So we have y is equal to f of x is equal to 2 raised to x. So again, just interchange. So x is equal to 2y. And then we can bring down this y by using log. Okay, so whatever is the base here will be the base of your log now. So log of 2 of x is equal to y. So in that case, we were now able to bring down y. Okay, and then again, just simplify for y. So y is equal to log of 2 of x. Thus, your inverse function of x is equal to log of 2 of x. But if you're not familiar with log, you're much more used to ln, okay, then you can use this one instead. So this one is much more easier. So we have here the interchange of x and y now. So just multiply both sides by ln, okay? And then from there, you can now bring down the exponents. So as you can see right here, we have 1 here, then just bring down here. But then since it's 1, then we can just ignore that 1. So we'll just have ln of x. But from here, we can actually bring down the y. So y times ln of 2. Then from there, we can now simplify this expression. So y is equal to ln of x divided by ln of 2. So both of those are correct if ever they have a value of x, like for example, log of 2 of 1 and then ln of 1 divided by ln of 2, you'll get the same answer. So that is why both of those solutions are correct. All right. So if ever that you're not familiar on how to do this one using log and ln, then please search this one on the internet or on YouTube, okay, on how to bring down an exponent, okay, and a certain equation. So were you guys able to follow with our example number 3? Or no?
No, sir.
No.
Medyo, sir.
So medyo. So if it's a no, if it's a little, medyo, okay, please go back to your algebra, okay? Recall everything. Or you can just search for a website that talks about algebra, okay? Algebra 1 and 2. So in that way, you'll be able to understand more on how to simplify a certain equation. All right, so let's have more example here. So we have 2x plus 4. I guess this one is super easy. Just apply those 4 steps. So I will leave the analysis part with you guys. So we have number 1 here and number 2. And then you will arrive with this answer or this answer and then this answer. Okay, so I will skip this one now and I will leave this one as your self-study example or assignment. So once you're done with those examples, then you may now proceed in answering this Seatwork number 7. Okay, so just find the inverse function of the following. So we have a to I. All right. So mapapalaban kayo dito. You really need to go back with your algebra 1 and 2, especially with those exponents. Yun pala. Dali lang yan. Yeah, this one. Maybe this one is a little bit hard. But the rest, super easy. All right, so that's it for Seatwork number 7. And we have here the inverse function of a graph. But we have an example here wherein it is saying that we cannot do an inverse function of this since this one is not onto. Okay, and at the same time here we cannot also do the inverse function of this one because this one is not one-to-one. So the only time that you can do the inverse function of a certain graph is if they are only a bijection. So they must be an onto and a one-to-one function. All right. So I wasn't able to put an example here anymore. But anyway, as long as you guys already know the concept of bijection or one-to-one and onto, then you're good to go. Okay. So are we clear so far up to this point? Hello guys, are you guys still there?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So were you guys able to follow this one, inverse function, when it comes to graph? Hello guys, nasundan po?
Yes, sir.
Practice lang, sir.
Yeah, definitely. That's one thing that you really need to confirm with this one, okay? So we have here compositions of a function wherein we have this format, f of g times a. All right, so I know it's quite confusing, especially when it comes to analyzing what is this arrow all about, what is this diagram all about. But basically we have 3 results here. We have, let's say, the function g of a, function of f, and then function of the a. So those are just my assumptions. So that depends on the values of those Venn diagram. Okay. So as you can see right here, we have f, g. Okay. So we have to simplify those f of g times a. So enough with that. So I know that you guys are still confused. Anyway, let's have this example for you guys to be able to understand with what is this f of g of a. So now we have now here the values of your f and then the value of your g. Okay. So the one thing that we need to check first is the value of your a. Okay. So you have to know what is the value of your a. So in here we have 1. So whatever is that a, you have to substitute that 1 to your g of x. So take note, you have to substitute that to your g of x, not to your f of x. Okay, so g of x first. So we have here 1, right? So 3 times 1 plus 2 is equal to 8. Is that correct? Are you guys able to follow on how did we get the answer 8? So 3 times 1 plus 2. 3 times 1 plus 2 is equal to 5, not 8, sorry. So 3 times 1 plus 2 is equal to 5. Okay? So were you guys able to follow?
Yes, sir.
Okay? So don't look on your f of x for now. So just go to the value of your a, substitute your g of x, and then once you have simplified your g of x, which is equal to 5, then that's time that you can now substitute your g of x to your f of x, wherein your g of x is equal to 5. So 2 times 5 plus 3 is equal to 13. Right? So that is actually my way of solving this composition. Okay, using my or manual or impromptu using my mind only. But if you're going to show it on the solution, okay, or with solution, then same concept, but a longer solution. So basically, we have the 2 times x plus 3 for your f of x, right? So whatever is the value of your g of x, you have to substitute that one to your x in here, okay, which is now this one, 3x plus 2 plus 3. And then the last one here is simplify this one and then substitute the value of your a or your x, which is 1. Okay, that is why we have this 6 times 1 plus 7 is equal to 13. So that is another way of solving this one, okay, using via paper, okay, because you have to simplify that and then get the value of your a, then substitute it again, and that's the time that you will be able to get the f of g of 1. Okay, but if you want to do it using your mind only, then you can apply what I did. Okay, so substitute this one right here and then get the value, and then whatever is the total of this g of x, substitute it and then compute, and you will get the same answer, which is 13. So were you guys able to get that one?
Yes, sir.
So don't look on our drawing. It might just confuse you. Anyway, if you were able to understand this one, then very good. All right, so we have another example here wherein we have the uh, a is equal to 2, and then g of x is 3x plus 2. Again, let's just substitute this 2 here to your g of x. So 3 times 2 plus 2 is equal to 8. And then 8 will be substituted to your x in here. So 2 times 8 plus 3 is equal to 19. That's how I do it manually. But with solutions, then you have to follow just like what we did in here, or just like this one. We have the same process. So g of 2 first, followed by f of 8. But in here, it wasn't one time shot. All right. Anyway, so were you guys able to follow the solution and then the answer?
Yes, sir.
Yes, sir.
All right. So we have another example here wherein we have 1a, 2a, 3c, ay, bx, and then cz. So how did we come up with 1y, 2y, and then 3z? Let me just show you guys the step-by-step solution. So first, we have to know the values of your domains. So we have 1, 2, and then 3. And then the next one here is A, B, and C. And then for the last one here, we have A, B, and C. So the same for the domain. And then C is Y, X, Z, or X, Y, Z. So we have 1A, 1 going to A, 2 going to A, 3 going to C. And then we have AY, A going to Y, sorry for that, B going to X, and then C going to Z. So as you guys can see, if you're going to simplify this one, we have 1y. And then we have 2x. Then we have 3z. So that's how we've got those answers. Oops, sorry. This one is 2y. This one is going here, not there. All right. So did you guys able to understand that one? On how we've come up with 1y, 2y, and 3z? Guys? Yes or no?
Yes, sir. Yes, sir.
Yes, sir.
All right. So we will stop here for now. Okay. So Seatwork 1 to 8. So we still have 12 more slides, but we don't have enough time anymore. Okay. So we will just continue the rest next meeting. Okay. So we're going to have a short meeting next meeting. All right. So that's it. Goodbye and thank you guys for coming.
Bye,
Goodbye.
sir.
Thank you, sir.
Sir.
Thank you, sir.
Thank you, sir.
Thank you too.
Bye.
Goodbye.